So your flight's delayed, maybe it's been diverted, or it's just really, really bumpy. And the reason they give is weather. But what does that actually mean? Well, it's a high-stakes battle against an invisible enemy that started hours ago. Today, we're going to pull back the curtain on aviation weather. This incredible fight of prediction versus physics that happens long before you ever step on the plane.
You've been there, right? It's a classic travel moment. Beautiful, clear blue skies right outside the terminal window, but the departure board says, delayed for weather. And you're thinking, how is that even possible? Well, it's because the weather that matters for your flight often has absolutely nothing to do with what's happening right there on the ground. It's all about what's happening miles away and tens of thousands of feet up in the air.
You see, this whole process kicks off hours before you even think about boarding. It's called the pre-flight briefing. This is where pilots and dispatchers basically become meteorologists, digging through streams of data to chart the absolute safest path through the sky.
And look, this isn't just them being extra careful, it's actually the law. Federal regulations are super clear on this. Every single pilot in command has to be familiar with all available weather information for their flight. Not some of it, not most of it, but all of it. So, what are they actually looking at? Well, they start with two really fundamental reports. First is the METAR. Think of it as a snapshot, what's happening at the airport right now. Then there's the TAF, which is the forecast, what's expected to happen over the next day or so. One tells them what they're leaving behind, and the other tells them what they're flying into.
Okay, so with that data in hand, they have to make a huge decision about how they're going to fly. Under Visual Flight Rules, or VFR, a pilot can just look out the window and navigate. But if clouds or fog roll in, they have to switch to Instrument Flight Rules, or IFR. That means they're relying completely on the aircraft's advanced instruments to get around. So you see, the weather literally dictates the rules of the game.
All right, so the pilot's got a plan. But what are they actually planning for? Let's take a step back and look at the fundamental forces that create the weather in the first place, the things that can turn a perfectly clear day into a major challenge. At its most basic level, weather is all about pressure. Think of it like this. High-pressure systems are where air is slowly sinking. That sinking motion actually stops clouds from forming, and it generally gives you fair, calm weather. Low-pressure systems are the complete opposite. Air is rising, and as it rises, it cools. Moisture condenses, clouds form, and you get stormy, unstable conditions. Pilots are constantly tracking these highs and lows all along their route.
And those pressure systems? They're really just tiny gears in this massive, planet-sized weather engine. See, the Earth heats up unevenly, which creates these huge, circulating cells of air. You've got one in the tropics, one at the poles, and this feral cell in the middle that drives most of our weather. Together, they're just constantly shuffling heat and moisture all around the globe. So, how does all that big picture motion create the stuff pilots really worry about? We're not talking about a little bit of rain here. We're talking about three powerful, often invisible phenomena that pilots are trained to respect and avoid at all costs: thunderstorms, icing, and turbulence.
You know, a thunderstorm isn't just one thing. It's got a life cycle. It starts as a towering cumulus cloud, and it's all about powerful updrafts sucking air upwards. Then it hits the mature stage. This is the most dangerous part, with a violent mix of updrafts and downdrafts, creating heavy rain, hail, the whole shebang. And finally, it gets to the dissipating stage, where the downdrafts take over and the storm basically rains itself out.
And to give you a sense of the raw power we're talking about here, get this. Those updrafts inside a developing storm can rocket upwards at over 3,000 feet per minute. That's a vertical wind so strong it can toss an airplane around like a toy. It's an incredible, invisible force.
This is exactly why the rules about thunderstorms are so strict. You just don't mess with them. The guidance is crystal clear. You never take off or land if one's approaching. You give any severe storm a huge buffer, at least 20 miles, and you never ever try to visually weave your way between a line of them. The risks are just way too high.
All right, the next big hazard is icing, and it all starts with this really weird, kind of mind-bending physics concept: supercooled water. These are tiny water droplets floating around in the air at temperatures well below freezing, but they haven't turned to ice yet. They're in this fragile liquid state, just waiting for something to smack into. And when an airplane wing smacks into them, they freeze instantly. This can form two types of ice. You've got rime ice, which is brittle and easy to see, but the one that really gives pilots headaches is clear ice. It's dense, it's almost invisible, and it can spread back behind the de-icing equipment on the wings, completely ruining their shape and their ability to create lift. And finally, Let's talk about that bump you feel on a perfectly beautiful, clear day. That's called clear air turbulence, or CAT. It's not caused by storms. It happens when two big chunks of air right next to each other are moving at drastically different speeds, something called wind shear. It happens a lot near the jet stream, and it's a totally invisible atmospheric minefield that can pop up with zero warning.
So, how in the world do you fight an enemy you can't see? Well, the answer is a massive, coordinated, global network of technology and people all working around the clock to make the invisible visible. So, the first line of defense is right here on the ground. It's the NexRad Doppler radar network. We've got 160 of these sites across the country, and they're constantly scanning the sky. They don't just see rain, they see how the wind is moving inside a storm. This lets forecasters see a storm's structure, its rotation, and just how intense it is. Then you look up, way up, and you've got our weather satellites. Geostationary satellites just hang out over one spot, giving us a continuous movie of how weather systems are evolving. Polar orbiting satellites, on the other hand, scan the entire globe, giving us detailed pictures of everything, especially over the huge oceans where radar can't reach. But radar and satellites give you a pretty flat picture, right? To see what's happening vertically from the ground up, we use weather balloons. Twice a day, all over the world, these balloons are launched carrying a little instrument package. They float up through the atmosphere, sending back a complete profile of temperature, pressure, and humidity, giving us a crucial 3D picture of what's going on. But with all this amazing tech, you know what one of the most critical tools is? People. Specifically, pilots in the air making what are called pilot reports, or PIREPs. If a pilot hits some turbulence or icing, they can report its exact location and intensity right then and there. In that moment, they become the eyes and ears for every other plane nearby. And think about it. A pirate might be the first and sometimes the only sign that there's a hazard out there that the forecasts missed. That sudden patch of turbulence or that unexpected layer of ice might only be known because one crew took the time to report it, letting air traffic control warn everybody else. It's an absolutely critical link in the safety chain. Okay, so we've got the forecasts, we've got the radar, we've got satellites, and we've got pilots on the radio. How does this all come together to actually keep a flight safe from gate to gate? Well, it all gets boiled down into things like a SIGMET. That stands for Significant Meteorological Information. And a SIGMET isn't just data. It's an instruction. It's an urgent warning for things like severe turbulence or widespread icing. When a SIGMET is issued for an area, it's a clear signal to every pilot. This area is hazardous. Stay away. This is how all that information gets turned into real-time action. So the next time you're on a plane, and maybe you're sitting on the tarmac looking out at a perfectly sunny day, wondering why you're not moving, just remember the unseen battle being waged. Your flight crew and this whole global network of people and technology, they're navigating invisible rivers of wind, they're dodging supercooled water, and they're charting a course around towering columns of violent air, all of it just to make sure your journey is a safe one.